Now this is a block which is tied to spring. It is stretched over here and left. So what would happen? Obviously simple harmonic motion. So while it is being stretched over here, so it would, once you stretch it and leave, then it would have simple harmonic motion. Now suppose the block is over here in stretched state. Alright, this is stretched state and this is compressed state. Alright, you can see it is compressed. Alright, so we would call it as compressed state and stretched state. Now when this is in stretched state, there is some force which is pulling it back. That's the reason why it gets into compressed state. Now that force is called as restoring force. Alright, now that restoring force is directly proportional to displacement. Alright, and we find here negative. Can you guess why? It's because the restoring force direction is this side, whereas displacement is in this direction. Again, if you check out in compressed state, the displacement is this side and restoring force is this side. So all the time you will find that the force would be towards the mean position. Restoring force would be directing towards the mean position. Alright, that is what it is. So now let us talk a little bit about displacement, velocity, acceleration and force. See, whenever it comes over here, this is the amplitude I told. So the displacement x is maximum. Now we know once it comes over here, velocity is 0. Only after that it would go back. Velocity would be 0. Now what I say is acceleration and velocity have 36 ka aakada. Hindi 36. So this is 3, this is 6. So both are opposite to each other. So if we 100% know that when it comes to the extreme, the velocity becomes 0. So acceleration would be maximum. This is just a way to keep it in mind. Alright, okay, not to get confused, because 100% we are sure only after velocity being 0, it is going to retreat back. So we know that at extreme position, velocity would be 0. And if velocity is 0, since 36 ka aakada, so acceleration has to be maximum. Alright, now if acceleration is maximum, force also has to be maximum, because force is mass into acceleration, mass is constant, so acceleration, it would depend upon acceleration. Alright, fine. Alright, so now what happens is it comes over here in the mean position. So what happens in mean position? In mean position, obviously displacement is 0. Now, the way to keep in mind, now here we know velocity was 0. So here in mean position, velocity would be maximum. I again repeat, this is just a way to keep it in mind. Velocity would be maximum. These all things will prove theoretically. Okay, we would derive these things later on. So velocity is maximum. Velocity was 0 here. Velocity is maximum here in mean position. Now if velocity is maximum, remember that 36 ka aakada. So acceleration would be 0. Now acceleration is equal to 0. Then force is equal to 0 also. Why? Because force is equal to ma. So understood this part. Now this part is identical to that part. Alright, so it would be like that only. X is maximum, velocity is 0. Since velocity is 0, acceleration is maximum. Since acceleration is maximum, so force also would be maximum. So this is what we understand from this. Alright, so let us get into a bit of derivation, small derivation. Now restoring force directly proportional to minus x. I explained you why is it negative over here, because both are again 36 ka aakada. This is restoring force. If it is towards this extreme, restoring force is this side and displacement is this side, and if it is towards that extreme, then restoring force is this side and displacement was that side. Alright, so F is directly proportional to negative x. Alright, now when this goes, obviously we know one constant of proportionality comes, and that is k. So F is equal to minus kx. Alright, then we also know that force is equal to mass into acceleration. Alright, very old formula, right? So force is mass into acceleration. So acceleration would be what? Force divided by m. So if I am correlating these two, then acceleration would be k divided by m. So you can also write formula for acceleration is equal to minus k over m into x, where m is mass of the block, x is the displacement that it is taking. Now here we are not talking in terms of amplitude, any displacement, it could be somewhere here, there, anywhere. So x is displacement and k is proportionality constant. All right, so this is the formula that you have got to keep in mind. Okay. All right, we also need to know this. Linear SHM is equal to linear periodic motion of a body in which force or acceleration, force and acceleration would be same, right? Because mass, which is a constant stuff. So force or acceleration is always directed towards mean. That is what I explained already. So when it is stressed over here, the restoring force is directing there. When it is compressed here, the restoring force is directing this side. All right, so towards, and we know this is mean position. So in which force is always directed towards mean. All right, and its magnitude is proportional to displacement from mean position. Obviously, you know that, right? If you stretch it more, restoring force also would be more. All right, so if you stretch it more, restoring force also would be more, and it would be going that side also more. So again, restoring force would be more. So its magnitude is proportional to displacement from mean position. All right, so this is one thing which you should keep in mind when we are talking about these things. Now, having known these things, let's proceed into derivation, into trying to prove what all we told right now. X is equal to 0, v is equal to mx, maximum x is equal to 0, v is maximum acceleration is equal to 0 when such is the state, and here when such is the state. These are the things that we get. Let's get it out via derivation.